Often, the equation of a curve is not given as y equals f of x, but instead, both x and I are given as a function of a third variable. In this case, let's say t. When this is the case, the equations are called parametric equations and are interrelated by the third variable t. So if you have y equals f of x, it may be obtained from y of t and x of t by eliminating t between them. So when a function is given in terms of parametric equations, the problem is generally best solved by performing operations such as differentiation separately on each of the parametric equations and then combining the result. For example, we have here an expression y equals f of t, and then we have x equals f of t. So how do you find derivative of y in terms of x? By chain rule, this can be equal to dy dt times dt dx. Or since you're given x as a function of time, instead of expressing dt dx, we get the reciprocal of that and write this one, this, in this form. So we divide our dy dt by 1, we multiply it by 1 over dx dt, or another way, we write it as dy dt divided by dx dt, right? So just like a times 1 over b, it's just a over b. So this is what happens in this line here. And so we write dy dt divided by dx dt. Okay? We can obtain the derivative of the y with respect to time. And what is the derivative? So what's the derivative of f of t, which is in terms of, or this refers to the y. So what is the derivative of y with respect to time? If you have time, no? I associate t with the time. Kasi parametric equation is associated with direction of motion. When you apply this to physics, you can graph this function. Although dalawang function ito, meron tayong y as a function of time or t, and x as a function of t. Kaya siya ginamit na t kasi time talaga yan. You can graph this one, class. This is a direction of motion. So how do we find the first derivative? We derive y as a function of time divided by x as a function of time. How do we obtain the second derivative? Second derivative is the derivative, of course, of the first derivative, which is this one. Derive natin yan. And using again the chain rule, we could say that the derivative or the second derivative of y with respect to x would just be equal to the derivative of this one, divided by dx dt. So if I'm going to illustrate this one, say we have an example. First, you find the derivative of your, unahin natin si y. Derivative of y. Or in other words, what's the derivative of t minus t cubed? So that's just equal to 1 minus 3t squared. What's the derivative of t minus t squared? That's just equal to 1 minus 2t. So from the formula, the first derivative of this parametric equation is equal to dy dt divided by dx dt, so that we write 1 minus 3t squared divided by 1 minus 2t. Okay. And how do we obtain the second derivative of y with respect to x? It's just equal to the derivative of 1 minus 3t squared divided by 1 minus 2t, yan, divided by dx dt. So this is your dy dt. This is your dx dt. So we apply the derivative, low 1 minus 2t, derivative of the high, which is negative 60, minus high 1 minus 3t squared, derivative of the low, which is negative 2. Sorry, this is negative 2. Over low squared, 1 minus 2t squared. But we still have to write dx dt, which is 1 minus 2t. So that is how you're going to derive. And simplify this. We can join these two. This one and this one. Isn't it? Remember that this is your numerator, this is your denominator. It's just like saying a over b all over b is equal to a over b squared. So we can join these two. And so we have 1 minus t quantity cubed as our denominator. So we will simplify second derivative of y with respect to x of this parametric equation. We are going to distribute the negative 6t, and then we have positive 12t squared. Right? And then this one times negative 2. So that gives us positive 2. And then this one also. This is triple negative. So negative, another negative, and then you have another negative. So the answer is negative 6t squared. Okay. We can still simplify this. We can combine this two. So I guess this is our answer. Now, how does this one behave? Like what I said a while ago, igagraph nyo siya. Pero this has nothing to do with the differential calculus class. No? Let's say you deal with functions and you're going to graph this type of function, which is a parametric equation. You take note that we have this two. And so you have, let's say, x equals t minus t squared. Your y is t minus t cubed. Isn't it? So you assign values of t. Say you tabulate. And so you start with the t. And then this is for the x, this is for the y. So say your t, you start with negative 1, you assign value of, let's say 2, 1, 0, 1, 2. And then you obtain the corresponding x and corresponding y. So when x is negative 2, you have x equals negative 2 minus negative 2 squared. That gives you negative 2 minus 4. So that is negative 6. And for the y, you have negative 2 minus negative 2 cubed. So that's negative 2. And then this, of course, is still is negative. Negative and negative becomes positive. So you have 8. So we have here 6. And so on. No? And then you graph that in the xy plane. Ito siya. I-graph mo yan sa xy plane. Para makita mo yung direction ng motion. Let's say I'm going to just refer you to this side class. This is one parametric equation. X equals t squared plus t. And the other one is y equals 2t minus 1. So okay lang to kasi this is a line. This is a second degree function. So if we're going to graph this one, this is how it looks like. So you can see, ayan, this point here, itong negative 3, that is for values of x equals 0 and y equals negative 3. So you have t equals negative 1. And then t equals negative 1 half for x equals, I guess this is x equals negative 1 half and y equals negative 2. Now for this, your x is 0 and your y is negative 1. And another point, this is when your x is positive 2 and your y is positive 1. So there has to be a direction. That's why you can see arrow. So if I'm going to say t as time, at motion ito ng isang object or isang particle, at time equals 0, andito siya. Ito yung reference. At time equals 0, andito yung location ng object. At x equals 0 and y equals negative 1. After 1 second, nandito na siya. Ito na yon. So, it's a path, no? It's a pwedeng tawagin nating trajectory path ng isang particle that is pwede ring in orbital motion, and yung path niya is defined by this definition, these functions, x equals t squared plus t and y equals 2t minus 1. This is with the condition that t is between negative 1 and positive 1. Right? Yan ang parametric. This one is a trigonometric function. Ano naman ang pag-trigonometric function? Makikita nyo, if we're going to show the solution, ganito yung pag-graph sa kanya. In this case, naka-pi values. Ano yung corresponding value ng x, ano yung corresponding value ng y. At i-graph mo siya, ito pala ay ellipse. No? So, and many others. May give you an example on trigonometric functions. Say you're asked to find the second derivative of y with respect to x. You can also, by the way, use another notation. Pagka may makita kayong ganyan, tapos ito, that is the same as this one. Second derivative of y with respect to x. Given, okay, so again, you derive. What is your dy, unahin natin si y, dy d theta. So derivative of this one, 4 tangent theta plus 2 is 4 secant squared theta. Tama? And then derivative ng x with respect to theta is 2 secant theta tangent theta. So that your first derivative of y with respect to x is the quotient or the ratio of dy dt and dx, no, dy dt theta, dx d theta, which is this one. Okay, and you can still simplify this. You can cancel the second, second sa baba. So you're left with a single second theta. And then you have tangent of theta. Okay. So this is your um, first derivative. How do we proceed with the second derivative natin? So we derive our first derivative. That's equal to low derivative of high, which is second theta tangent theta, minus high derivative of low second squared, divided by tangent squared theta. Kasi low squared. Pero meron ka pang dx dt. And your dx d theta. 2 second theta tangent theta. We have 2 second theta tangent squared theta. And so we have 1, 2, 3 terms. Tangent. Bakit minus to class? This is not minus, di ba? Low derivative of high. So times ito. So 2 terms lang tayo. So we have 2 second theta tangent squared theta minus 2 second cube. Okay. And so I think we can make use of a identity. We have an identity, still remember, 1 plus tangent squared theta equals second squared theta. And so we can factor the numerator. They have 2 similar terms. We can factor the second and the 2, coefficient na 2. So we can write this as 2 second theta. Ang naiwan dito is tangent squared theta. Sa kabila, meron tayong second squared theta. Divide by 2 second and tangent squared theta. Theta. Okay. We can cancel this. But what is tangent squared theta minus second squared theta? From our identity, na 1 plus tangent squared theta equals second squared theta, we can write tangent squared theta minus second squared theta equals negative 1. So therefore, this is negative 1. And we have negative 1 over tangent squared theta. Or could have negative cotangent squared theta. Okay. So that's our answer, class. Well, this is supposed to be cube. And so this is cube. And so this is cube. And this is cube. Okay. Questions, class?